So welcome everybody to this latest A2 video on series and sequences, and in this video we'll be continuing with arithmetic progression, and we'll be working through and showing how to derive the sum of n terms formula. Now, an arithmetic series is when a sequence of numbers with a common difference appears as a sum of numbers. So if we took an arithmetic sequence, so let's go for 3, 5, 7, 9, 11, and obviously that would then continue to our nth value. Then if this represents a sequence, then to represent a series, all I need to do is stick a plus sign in between each of those. Now if I want to represent this algebraically, then all this would be a is our first term, then we've got a plus d, then we've got a plus 2d, then we've got a plus, and then we've got a plus 3d and a plus 4d. And if I wanted to turn this into a series, then all I need to do is stick a plus sign in between each of these, and then our last or second to last value would be a plus n minus 2d, and our last term would be a plus n minus 1d. And obviously this represents our nth term formula. Now, by writing an arithmetic series algebraically, we can generate a formula that allows us to find the sum of n terms in an arithmetic series. So let's start off by taking what it is. So we're trying to find the sum of n number of terms. Now my first term is going to be a, my second term is going to be a plus d, my third term is therefore going to be a plus 2d, and that's going to continue until my third to last term, which is going to be a plus n minus 3d plus a plus n minus 2d plus a plus n minus 1d. Now if I just label what each of those terms are, so this is my first term, this is my second term, that is my third term, this is the third to last, this is my second to last, and this is my last term, or the nth term. So now if I then flip the order, so let's say I'm going to write, as we're adding, it doesn't really matter what order we add in. So what I'm going to do is I'm going to write Sn equals, and let's say we start off with our last term, is 1 minus d, then we've got a plus n minus 2d plus a plus n minus 3d plus, and then our third term is a plus 2d plus a plus d plus a. So all I've done is just simply flip the order. Now if I just label these as hashtag 1 and hashtag 2, so if I now add together hashtag 1 with hashtag 2, then what do I end up with? Well, I end up with, let's just get a different color, I end up with 2Sn equals, now if I add together these two things here, add together those, add together those, add together those, add together those, and add together those. Now if I just do this on the side, so if I just label this as, doing a lot of labeling, as number 1, number 2, number 3, now that is going to be exactly the same as this one, 2 is going to be the same as that, and 3 is going to be the same as this. Now to show in terms of number 1, so let's just add those together. So with number 1, we're going to end up with a plus n minus 1d. Now if I expand the brackets, I end up with a plus dn minus 1, minus d, sorry, and if I simplify that, what do I get? Well, I get 2a plus, and then it's going to be d n minus 1. And then for number 2, if I add those two terms, so I've got a plus d plus a plus n minus 2d. Well, again, expand the brackets, I end up with a plus d plus a plus, and it's going to be dn minus 2d. And again, simplifying that, what do I get? Well, I get 2a plus d, take away d is going to give me minus d, and then I've got plus dn, which then gives me 2a plus, and then it's going to be dn minus 1. And obviously with number 3, I've got a plus 2d plus a plus n minus 3d. And again, expanding those brackets out, what I end up with is a plus 2d plus a plus dn minus 3d. And again, collecting the like terms together, I get 2a plus n plus dn minus 1. Now, one thing you should be able to spot is that with every sort of addition of every single one of these terms, I'm going to get 2a plus dn minus 1. So what I'm going to do, so if I add those together, now how many of those am I going to end up with? Well, I'm going to end up with n number of those. So it's going to be an n number of 2a plus n minus 1d. Now again, what I then want to do is I want to make Sn the subject, so making, let's use a different colour pen. Purple. So then making Sn the subject, what I end up with is then I end up with Sn equals n over 2, and it's going to be 2a plus n minus 1d. Now, this is a formula that you are going to need to know. You are given, if you are given a formula book or formula sheet, but in your syllabus you will be expected, or you are sort of expected to know how to derive this formula. So following these steps is something that you are going to need to be aware of. I'll be honest, I've never seen this question come up in an exam, but it could easily come up. So in terms of this formula then, this is something that's definitely worth making a note of, which is the sum of n terms. And we've already got on to then derive this. So again, just reiterating what the components mean. So n is the number of terms that you're wanting to work the sum of, a is your first term, and d is your common difference. Now you can also, if you are not given what the common difference is, and let's say you're given what the first term is and the last term, then this is another formula that you can then use to work out what the sum of all the terms, or n number of terms, is going to be, and that is that Sn is also equal to n over 2 times the first term plus the last term added together. So as always, one of the best ways of understanding a particular topic is to go through some example questions. So let's have a look at this first one. So this first question says an arithmetic sequence which has 16 terms, starts 2, 5 and 8. And the first part of this question is asking us to find the last term. Now here it says in the question that it's got 16 terms, and so we just highlight that. So our last term is going to be the 16th term. So from this we can see that, well, from the sequence we can see that our first term is 2 and that the common difference is positive 3. So from this, to find our, so let's just write a, so our 16th term is going to be, well, writing down the sequence, and again the nth term is going to be for this one 3n minus 1. So to find the 16th term, n is going to equal 16, so it's 3 lots of 16 take away 1, and 3 times 16, so let's just quickly work that out, which gives me 48. So then it's going to be 48 take away 1, which is 47. Then for B, the question is then asking to find the sum of the first of the sum of terms of the sequence. So here what we've got is we've got n equals 16, we've got a equals 2, we've got d which equals 3, and our last term which is 47. Now, as I've already mentioned previously, that there are two formulas we can use. We can either use this formula when we know what a and d is, or we can use this formula when I don't know what d is, but I do know what the first and last term is. Now, in this particular question, I've got the luxury because I know both a, d and l. So let's just show you how we can get the same answer by using either formula. So Sn, so if I just take the first one, so let's just put this as hashtag 1. So in terms of using hashtag 1, we've got 16 divided by 2, and we've got 2 lots of 2 plus 16 take away 1 times 3. And so it doesn't look very nice, but let's just quickly work this out. So we've got 16 divided by 2, which is 8, and we've got 4 plus, and then 16 take away 1 is 15, times 3 is 45. So then what we've got is we've then got 8 times 49, and 49 times 8, which I should use a calculator, but just doesn't really matter. And then we've got 34, so that's 41, so it's 412. Now if I then wanted to use the second formula, so using Sn equals n over 2 a plus L, what we do is we get 16 divided by 2, and then we've got our first term, which is 2, plus our last term, which we've worked out as being 47, in which we're going to get the same calculation, so 8 times 49, which we get is 412. So you can see there that it doesn't really matter which formula we use. However, we tend to use hashtag 1 when you know A and D, and obviously N. And we use this formula when you know A, the last term, and obviously N as well. Now looking at our second example, so the question says that an arithmetic series has a first term of 3 and the sum of the first 20 terms is 288, and the question is asking us to find the common difference. So in terms of reading the information from the question, we can see that A is equal to 3, and we know that S of 20 is equal to 288. Now in terms of which formula do I use, well I don't know what the 20th term is equal to, so what I'm going to have to do then is use the fact that this is n over 2 2a plus n minus 1 d, and it's d is what I'm wanting to find. So in terms of this, I have to know that S of 20, which equals 288, let's write that later. So here I've got 20 over 2, and then I've got 2 lots of 3 plus 20 take away 1 d, and that all equals 288. So simplifying this, 20 over 2 is 10, and we've got 2 times 3, which is 6, plus 19d equals 288, and then expanding the brackets we get 60 plus 190d equals 288, and then all I've got to do then is take the 60, I've got 190d equals 228, so then d is going to be equal to, again just getting my calculator, 228 divided by 190, and it gives me 6 over 5. Now in terms of our third example, it says that an arithmetic series has a common difference of minus 0.5 and the sum of the first 25 terms is 350. So, and the question is asking us to find the first term. So again, very similar to example 2. So in terms of this, we know that a common difference is minus 0.5, so d equals minus a half, and S of 25 is equal to 350. So then in terms of substituting that in, what do we get? Well, we've got n, which is 25. So I've got 25 over 2. And then we've got 2a plus, now n is 25, so I've got 25 take away 1 times minus a half. And that is all equal to 350. So simplifying this, I get 12.5. It's going to be a lot of decimals, times 2a. And then we've got 24 times minus a half is going to give me minus 12, and that's all equal to 350. Then obviously we can either expand the brackets or we can take the 12.5 over to the side. So let's just expand the brackets. So I end up with 25a minus 12 times 12.5, which is 12.5 times 12 is 150. And then all I then need to do is go on to solve this for a, so I add 150, and that becomes 25a equals, and it's going to be 500. And so a equals 500 divided by 25, which of course is 20. Now looking at this fourth example, the question says that the fifth term of an arithmetic series is 24 and the ninth is 4, and the question is asking us to find the first term and the common difference. Well, in terms of the information that we're given, well, we know that the fifth term is equal to 24 and the ninth term is equal to 4. So if I just label this as A. So in terms of the fifth term, what is that? Well, that's going to be A plus 4D equals 24, and the ninth term is going to be a plus 8d equals 4. And again, how have I got that? Well, I've just used the nth term formula and then just swapped that these two numbers here are my n values. So from this, what you should be able to spot is we've got a simultaneous equation. So here we've got a plus 8d equals 4, a plus 4d equals 24. And we're going to subtract the 2, so the a's disappear. I've got 4d equals minus 20, not 50. That's going to write. It's going straight to the answer. So minus 20. So then, therefore, d equals minus 5. And then from this, we can then work out what our a is going to be. So a minus 20 equals 24. So a equals 44. And there are my two values that they've asked me to find. Now in terms of B, so the question here is asking, well, it's saying that the last term of the sequence is minus 36. How many terms are there in the sequence? So for here, what I want to do is, now you might be, common thoughts might be thinking, well, last term, it means then I'm probably going to be using that Sn equals n over 2 a plus l, because that's the only thing that I know that uses the last term. However, we're not being asked, it doesn't mention the word sum, so we don't use this formula at all. So what I want to know is which number of what position is minus 36 in the sequence. Now I could just simply start with 44 and keep taking away 5. I could do that on my calculator, but a much more efficient way of doing this is using the formula. So I know that in terms of the nth term, so n is what I'm trying to find. Well, I've got, if the formula for the nth term is this, then what I want to know is a, well, we know what a is. So here we've got that un, well, we know what un equals 30 minus 36. So minus 36 equals a, which is 44, plus n, which I don't know, but I do know what d is, which is minus 5. So if I then just go on to simplify this, and that's, don't really quite like the minus 36 on this side, so we'll write at the end. So here I've got 44 plus, or I should say minus 5n, and then it's going to be plus 5. So neatening this up, we've got 49 minus 5n, and all of this is equal to minus 36. So then taking the 49 over to the other side, I end up with minus 5n equals, and it's going to be minus 36 minus 49, which is minus 85, and then so therefore it gives me an n value of 17. Now we know that we should be expecting a positive number because I'm looking for a position, and obviously you can't end up in a negative position, so that does look valid. So now let's have a look at our last example. So this example says that the sum of terms in an arithmetic sequence with the first term of 5 and a common difference of 6 is 616. How many terms are there in the sequence? So for this, it says, well, let's have a look at the information. So we don't know what n is, so n is what we're trying to find. We know that a equals 5, we know that d equals 6, and we know that Sn equals 616. Now, in terms of this, we don't know the last term, so the formula I'm going to use is that Sn equals n over 2, 2a plus n minus 1. So from this, substituting numbers in, I've got 5, well I haven't, I've got n over 2, and then I've got 2 times 5 plus n minus 1, and then that's going to be times 6, and that's equal to 616. So from this, if I then just go on and simplify, so I've got n over 2, I've got 10 plus, and it's going to be 6n minus 6 is equal to 616. Now if I take the 2 over to the other side, I end up with n, and it's going to be 4 plus 6n equals, and that's going to be 616 times 2, which is 1232. And then from this, what I've then got is I've got 4n plus 6n squared equals 1232. Now this now, hopefully you'll spot, looks like quadratic. So we've got 6n squared plus 4n minus 1232 equals 0. Obviously then I can then simplify that by dividing everything by 2. So I've got 3n squared plus 2n minus, and divided by 2 is 616 equals 0. Now from this I can then go on to solve this, and it should, I reckon, factorize, but again, because I've got a calculator that can solve this for me, and just putting the coefficients in, so I've got 3, 2, minus 616, I end up with x minus 14, or should I say n, not x, and it's going to be 3n plus 44. So in terms of my values, I've got n equals 14, or I've got n equals 40 minus 44 over 3. Now it definitely can't be this, so n must equal positive 14.